Hi, everybody. Thank you for joining us today. I'm David Tarditi. I'm the VP of Engineering at Certicay, the leading blockchain security company. And so today I'm going to talk about blockchain and smart contract vulnerabilities. Um, so our focus is on securing the Web3 world. I'm one of the judges for the Revelation Hackathon. I've been looking at the projects. I've been looking at some of the pitch demos over the past couple of weeks. It is great to see all of these demos. It's great to see the energy and the innovation and the thought and the novelty and all of the work that people have done on their projects. And today I want to talk a bit as your projects grow, what security issues should you look out for? So just a step back, and I want to put you a little bit in the mindset of how a hacker thinks. Um, if you're trying to secure your project, hackers go after the easiest targets first. So they're going to look at socially engineering your users. They're going to try to attack your web UI front end. They might try to compromise your private keys or passwords. This is also called operational security. They can try to find flaws in your smart contracts, and they might target the bridges or blockchains themselves. And any one of these approaches might be what they take. They really look for what's easiest. So it's really important in terms of securing your projects that you think about the overall or end-to-end experience because there are definitely hackers out there, and they're definitely going to go after the easiest targets first. So let's talk about blockchain and smart contract vulnerabilities. So last year, hacks and exploits total up to $1.3 billion. And this is just in 2021. So here is a chart showing over time the total value lost to hacks and exploits in 2021. So, by the time we got to the end of the year, we're up around, 1.3 billion or so. So a lot of money is at stake in terms of making sure that you get things correct in your smart contract and blockchain programs. So some notable hacks, just to give you some examples of things that have happened in 21 and 2022. Uranium Finance in April of 2021 was doing an upgrade, and they were hacked for $50 million. It was omission of a single character. In October 2021, Compound Finance gave out $90 million in unearned rewards. It was a one-character mistake that wrote a greater than sign instead of a greater or equal to sign. In November of 2021, the DeFi protocol BZX was hacked for $55 million. And in this case, it was an attack on compromising the private keys. A developer was phished by emails. The hacker got the mnemonic seed phrase and the private keys for their Polygon and BSC deployments. In 2022, we've continued to see hacking activity. Qubit Finance, Wormhole, Meter.io, and Ronin are some notable examples. The total more than $1 billion so far, and we're only into April at this point. So if you're writing a program for blockchain, you want to write a secure smart contract, what are the things you need to think about? So I'm going to talk a bit today about what common security issues are in smart contracts, what are good coding and design practices, and how do you reduce risk? So Certicay is the leading blockchain security company. We cover everything from blockchain implementations to smart contracts. In the past 6 months through February, we audited source code for 1,427 projects. So we see a lot of smart contract and blockchain code. Because we see a lot of code, we're able to identify common code vulnerabilities and see what's happening across a wide range of projects. When we audited the projects, we classified the issues found in projects as critical, major, medium, minor, and informational. The critical and major ones are really the ones you have to pay attention to. They're really important. Medium also is important. And so we looked at those types of issues found in the audits and analyzed them to see, well, what are the causes that are behind, or what's causing these issues, what's frequent. So first, I want to back up a little bit. Some of you may not be familiar with how a source code audit works. So I'll talk here about how Certicay works to secure your source code. So here is an example of something that you would see on our leaderboard. If you click down here, and it shows for a project the kinds of vulnerability, the kinds of issues that have been found for this particular project. It was written in Solidity. There's one major, one medium issue, some minor issues, and some informational issues. There's a view PDF button here. So if you can see our reports, you can go to certik.com and just download a report and read it and see what's in it. What happens is the project team will provide source code for their project, ideally before publishing to the chain. CertiK security experts will review the code and provide a written report with issues. The project team and the security experts will discuss the report. The team can fix the issues or acknowledge the issues. If they acknowledge it, they say, we know it's an issue, but it's this way for this reason. After that discussion, after that remediation phase, CertiK publishes a final report on certik.com that everybody can read, everybody can see what was found during the audit and how the project team responded and what kinds of issues were addressed and what the project team's perspective was on issues. So let's jump in and talk about top smart contract vulnerabilities. We found 16,400 issues. 5,300 were critical, major, or medium severity. These are the kinds of issues you need to worry about. Critical issue means like you're going to get hacked. Major issue means there's some chance that you could get hacked. A medium severity issue means that it could be an issue, but maybe there's not so much value at stake, or maybe it's more difficult for a hacker to take advantage of that issue. So the number one thing that we're seeing in smart contract vulnerabilities is centralization risks. So an example of a centralization risk is where the owner can just update reward balances. We saw over 3,000 occurrences of that. The number two thing we're seeing is logical and correctness issues. So this is where there might be a calculation in the contract that's just wrong. Or there's some logic flow that is incorrect in the contract. The third thing we're seeing are withdrawal issues. So these are issues where a user can't get their value out of the contract for some reason. They can't get their money out. The money gets locked in the contract. And there were 140 of those issues. We also see access control issues. These are issues where there's a privileged function in your smart contract and anybody can call it. So like an example would be anybody being able to call Mint. We saw 120 of those issues. Finally, we saw contracts that are lacking limits or bounds. So this is like a contract that has no limit on fees. So, if the fee is adjustable, it means that somebody could potentially change the fee to be really high for operating the contract and drain value from the contract that way. And so the number of occurrences, we saw that 96. So I'm going to talk about centralization risks since this is by far the leading issue that we're seeing in our audits. A definition of a centralization risk is that it's a privileged role, such as the owner, that has control over one or more sensitive contract operations. So examples of this, if somebody who's running a project can update user account balances without any restrictions, and the issue there is that like if a hacker gets hold of their private keys for this contract, then the hacker could update the user account balances arbitrarily. They could take value away from users. Another example is withdrawals. So the ability of the project owners to send value locked in the contract, so the liquidity pool to an arbitrary address. The ability to withdraw all rewards. Another example is initial token distribution. So if all the tokens are sent to the contract deployer or externally owned address, that can be an issue too. If the tokens have some kind of voting right, an attacker could get hold of that EOA and take advantage of that. Also, there's economic issues that can happen where, you know, if somebody dumps a lot of tokens, it's going to cause the price to go downward. Contract upgrade is another example. And then being able to set the key parameters of the contract without limits. So sometimes we'll see, you know, a project that has multiple contracts in it. You want to make sure that if somebody can set key parameters, maybe there are some reasonable limits that you set to that. The point of centralization, the reason why centralization is such an issue is it's antithetical to DeFi. You have to trust the privileged role, not the code. So how do you deal with fixing or mitigating centralization risks? So this is just a sample of some of the kinds of things that you might see. So one threat is there's a leak of the private key for the privileged account. The consequence of this is that the hacker now has privileged power. So how do you fix or mitigate this? Well, the first thing is you can remove the functionality if it's really not needed. If you do need the functionality, you can implement it in code. If you've already deployed the contract and the functionality is already out there, you could renounce the privilege role. If you're still building the contract, you could secure the private key using a multi-sig wallet. You could use 2 out of 3 or 3 out of 5 signatures to make sure that, you know, the operation is something that you want to do. It's harder for a hacker to get hold of multiple signatures. They might have to compromise multiple machines or compromise multiple people to do that. And you want to use a time lock with that. So there's some delay, there's some visibility for the community. A final approach is to use a DAO for community approval. So, you know, a DAO is really putting the decentralization back in your project, back in your contract. Another threat is rug pull or internal operations. We all hear about this when it happens in the news, and token holders lose all their money. You know, and there can be insider threats or something like that. And again, you can remove or implement the functionality, or implement in code. If the contract's already out there, or you need the functionality for just like the startup part of the project, you could renounce the privilege role after you're done with the functionality. You can use a KYC service. So that's a know your customer service, and the owners of the project can be KYC'd. CertiK has a KYC service that we can go and check the background and identity of people running a project. And we can do this without the people running the project being doxxed. And finally, you can use a DAO for community approval. So I'm going to talk now about blockchain and bridge vulnerabilities. These are ones that have been making it into the news a lot recently. So there are 2 hacks in 2022 that were really notable. There was the wormhole bridge, $320 million lost. The cause of that was a smart contract bug. So they failed to validate input that one of the accounts you're transferring to was actually really the valid one to transfer to. It was your account. And then Ronin, there was $615 million lost. This is just in the news a few weeks ago. And this is a cross-chain bridge that involved a blockchain. And so they had a small blockchain validator network. I think it was like 7 or 9, I think it was 9 nodes. And the attackers managed to compromise the network of blockchain validators. And once you compromise the network of blockchain validators, they got the private keys to 5 of, I believe, the 9 machines, which means they get majority control. Then you can forge transactions at that point. You can take transactions and claim they're valid, even though they're not really. So what's going on here with blockchain and these bridges? The main issue that we see is that like bridges are much more complex than a typical smart contract. And so, you know, they're complex, they're big programs. You need deep domain expertise. For example, you know, you have to have multiple smart contracts operating on different blockchains, which means you have to understand how to program on those different blockchains. You have to understand the nuances of operating those blockchains. And similarly, if you're implementing your own blockchain, well, that's pretty hard. That's distributed programming. It's akin to systems programming. It's akin to like developing an OS. In both cases, as complexity goes up, the chances of making a mistake are easier, just more probable that you're going to have a mistake somewhere in a corner case. And we strongly advise in those cases, if you're building a bridge or you're implementing your own blockchain, that you get a code audit. So let's talk about best practices for securing blockchain programs, smart contracts, and bridges. And the slides here are focused mostly on smart contracts, but all the topics apply to bridges and if you're implementing your own blockchain. So the first thing is you really want to follow software design and implementation best practices. So write a white paper or design document. Make sure your design is written down. Use code reviews while you're developing code. If there are compiler warnings, fix them. Use static analysis tools during your software development process. For example, if you're writing a Solidity smart contract, there's a Slither tool that you can use. And make sure you write test cases for common and corner cases. So, if something you're not supposed to be able to do something, make sure that you have tests on your test net that check that you can't do that. And make sure that your common cases, like, and important cases actually work. Again, you should write tests, put this out on a test net, make sure that things work as expected, and that things that aren't expected to work actually, in fact, don't work. You want to follow source code, secure code best practices. So there's a lot of work in the broader software development community about how to write secure code, how to secure your OSs, how to secure your web services and things like that. The number one thing you can do is create a written threat model. So a threat model is, the idea is sort of what kinds of attacks can happen to your system. What are the worst case scenarios? So, your threat model can include compromise. You'll have regular users just doing normal things, but maybe they make an error. You'll have hackers who are trying to attack your code. And in the threat model, what you would do is you would have a diagram of the architecture, and then for each component in the architecture, like what could go wrong. I mean, you can also have things like a project owner is the only person who has the private key, and they pass away. So, the counter to that threat, of course, is to make sure there is some redundancy in how keys are managed. So you create a written threat model, then you analyze your software architecture and project operations with respect to that, and then you change your implementation and use mitigations like the kinds that I suggested, using multi-signature keys, multi-signature wallet instead of just a single private key. And the third best practice is get a source code audit. You want to get a source code audit, and if you make substantial changes to your code, you definitely want to repeat it. Even small changes, as I mentioned, the uranium finance hack was just an upgrade with a single character mistake. Even small changes may warrant an audit, but get a source code audit. Certicay has security experts review lots of smart contracts. We know what to look for. And we know we've probably seen your class of contracts before. So we can, having a second set of people looking at your code is really helpful. So with that, this is my high-level take on blockchain and smart contract vulnerabilities. Thank you for joining. If you want more information, you can visit certikay.com. You can get in touch with us at bd@certikay.com on our website. Also, we've got our Telegram and social media connections. So again, thank you very much for joining. Great to see all the projects, exciting stuff, and we're here to help you secure your projects now and in the future.